Okay, so to find the average rate of change, remember that this is x sub 1, this is x sub 2. I need to find y sub 1, which is equal to f of x sub 1, which is equal to 1 over 1 plus 3, or in other words, 1/4. I need to find y sub 2, which is equal to f of x sub 2, which is equal to 1 over 1 plus h plus 3, where this is replacing this x. And so this is going to be equal to 1 over, adding like terms, I have 4 plus h. Now, once I have my two y values, then I'm going to use the average rate of change formula, which is the slope of the secant line. So this is going to be equal to, we know it's going to be f of x sub 2 minus f of x sub 1 all over the x sub 2 minus x sub 1. In our case, our x sub 2, f of x sub 2, isn't a nice number, but it is a number. So 1 over 4 plus h minus 1 over 4 all over, and it is, my x sub 2 is 1 plus h, that's my x sub 2, minus my x sub 1, which is 1. What kind of questions do you have for me so far? Questions? Let's go ahead and move on. Was there a question? No? Okay. So moving on, what we have in the numerator, I'm just going to leave for a minute. I'm going to leave this as 1 over 4 plus h minus 1/4. In the denominator, I am going to clean that up. I have 1 plus h minus 1, so I just get h. Now we have two choices at this point. Choice 1 is that we make a single fraction in the numerator and then divide it by h. Or option 2 is I find out what my LCD, lowest common denominator of all of my fractions are, and then multiply every term within the net complex fraction, because that's what this is called. It's called a complex fraction because I have fractions within fractions. Now, I'm not terribly fond of finding a common denominator in the numerator, especially if I have fractions in the denominator. So I go through and I say, okay, my first fraction has 4 plus h. That comes from this one. My second fraction has a 4, so I need to multiply by a 4. And then my third fraction is divided by 1, so I don't have to worry about that. So now I'm going to multiply every single term by 4 plus h. And what that'll do for me is it'll clear my fractions. So in the numerator, this 4 plus h will cancel with that 4 plus h, leaving me just a 4 multiplied by 1. So I get 4. This 4 and this 4 cancel, leaving me 1, 4 plus h. So minus 4 plus h. In the denominator, nothing cancels, so I have every single piece there. So I have 4, and then h, and then 4 plus h. I'm going to stop and ask, do you have any kind of questions for me? What kind of questions do you have for me so far? So continuing on, what's going to happen is I'm going to distribute this -1 onto the 4 and the h. And so this is going to give me 4 minus h, all over 4h, 4 plus h. In the numerator, my 4's will cancel, giving me -h over 4h, 4 plus h. Then I'm going to cancel this h with this h, leaving me a -1 in the numerator and just 1 in the denominator. So my final answer is going to be -1 over 4 plus h. So does anyone have any questions for me? And can you all hear me? Okay. I just had somebody texted me privately and said they couldn't hear, so I just want to make sure that you all can hear me. What kind of questions do you have for me on this one? Because I'm going to have you try one similar to this in a moment. What kind of questions do you have for me? Again, you can unmute yourself, or you can raise your hand virtually, or you can type it in the chat. All right, if nobody has any questions to do, I'd like you all to do this one. I'm going to kind of expand out so you can see the work that went into it. I want you to do this example where my function f of x is equal to 3 over x minus 1. And I want you to find the average rate of change on 2 and then 2 plus h. So if you all could find the average rate of change on that, and it should be something similar to what we just did, and I'll leave the work up for you. So go ahead and work on that one, and then when you have an answer, you can put it in the chat, or you can just say it, or you can give it to me privately. I'll give you a couple of minutes to work on that, and then I will do that. Did anyone have an opportunity to finish and get an answer on this? Or are you all still working on it? Are you all still there? I guess that's the other question. Are you all still there? Has anyone had an opportunity to... Okay, so let's go ahead and go over this. So, like before, this is my x sub 1, and this entire beautiful thing is my x sub 2. So I'm going to go ahead and put x sub 1 in, and the reason I have to put x sub 1 in is because I need to find y sub 1. And y sub 1 is going to be equal to f of x sub 1, which is going to be 3 over 2 minus 1, which ends up giving me 3 over 1, or in other words, just 3. I need to find y sub 2, which is going to be equal to f of x sub 2, which is equal to 3 over 2 plus h minus 1. Again, this 2 plus h is going to replace that x. So this is going to be equal to 3 over 1 plus h. Now that I've found my y sub 1 and my y sub 2, I'm going to find the average rate of change, which is going to be equal to the y sub 2, or f of x sub 2, which is 3 over 1 plus h, and then minus my f of x sub 1, or y sub 1, which is 3, and then that's going to be over my y, or x sub 2, which is 1 plus h, minus my x sub 1, which is 1. So this is going to be 3 over 1 plus h minus 3 over just h. My in the denominator, my minus 1 and positive 1 will cancel themselves out. And like before, I'm going to find my lowest common denominator. My first one right here, my first term, gives me as a denominator 1 plus h. My second one right here is over 1, so I don't have to worry about that. And then my third term is also over 1, so I don't have to worry about that. So I'm going to multiply every single term by 1 plus h. And when I do that on my first term, the 1 plus h cancel, leaving me just 3. So this is going to be equal to 3. My second term, when I multiply it through, I have no cancellation, so I have 3, 1 plus h. And then the denominator, I'm going to have h, 1 plus h. I'm going to distribute the 3 through, so 3 minus negative 3 minus 3h, all over h, 1 plus h. In my numerators, the 3's will cancel, leaving me negative 3h over h, 1 plus h. My h's cancel, leaving me just negative 3 over 1 plus h. Does anyone have any questions for me? What kind of questions do you have for me? So I'm going to put this on pause. Now what we're going to do is we're going to find the average rate of change on a graph. So if we come back to our graph example here, they're asking us to find the average rate of change between 1 to 4. We talked a little bit about this briefly yesterday, is when I have it in this form, I could have said that the average rate of change from x equals 1 to x equals 4, or I could have wrote this as on 1 to 4, and the assumption is when I see the word on 1 to 4, then it's an interval in which x1 is 1 and x2 is 4. So if I have the graph, then I'm going to go where x is equal to 1, and there is my output, it is 5. And I'm going to go where x is equal to 4, and my output is 7. Now, if I have a grid and it works out nicely, my average rate of change is delta y over delta x. Now remember from yesterday, the delta just means change. And so if I have the ability to just look at the graph, I can do the change in y. So here's my delta y. It happens to equal 2. And then here's my delta x, which happens to be 1, 2, 3, 4. Delta x is equal to 4. And so my final answer is just 1/2. And it's positive. And the output for 4 should be... Okay, so when we are looking at the graph, we just figure out what... Oh, yeah, I went to 5, didn't I? Ah, thank you. So let me go to the right one. Thank you for that. I went to 5. Man, okay. So here's my x sub 1. Then I go to 4, and it is on 4. It is actually about 3.5 is where the output is. So same kind of thing though, is I'm going to do the delta y. So from here to here, delta y. And it looks like I dropped about negative 1.5. Looks like I came down 1.5. So negative 1.5 for the y. And then my delta x should be 3. So my change in y over my change in x is negative 1/3 divided by 3. And what we found was this line that I just drew. This is called the secant line. Secant line. It's a line that's not initially on the graph, and I am just drawing the line to 2 points that go through the graph for a nonlinear. That is the secant line, and what we just found was the slope of the secant line. And so I typically don't leave a decimal within a fraction, so I'm just going to rewrite this as a fraction. So negative 1.5 is negative 3 over 2 divided by 3. And now that I have a fraction over a fraction, I write this as negative 3 over 2 multiplied by the reciprocal, which is 1/3, reciprocal of the denominator fraction. So my final answer is negative 1/2. Does anyone have any questions for me? So let's talk a little bit about what it means to be increasing, decreasing, and constant. So when I'm talking about increasing, I'm talking about as the graph goes from left to right, what do I expect it to be? Okay, so the question, so going back to this before we move on, the question is x would equal 3.5 or 3. So when we are looking at, I'm assuming the question is in reference to the slope. When we're looking at the delta x and the delta y, if I have the ordered pairs here, so my ordered pair for my first ordered pair is 1, 5, and my second ordered pair is 4, about 3.5. Now, if I don't have the graph, the grid, and I'm just given the ordered pairs, then the way in which I find the delta y is going to be the 3.5 minus 5 over the 4 minus 1. And so if I don't have the grid and I'm just looking at the ordered pairs, I'm still going to get the negative 1.5 divided by 3. And then I'm going to use the fact, so what I did here was I used this rule that says if I have A over B divided by B over C, D over C, then this is going to be A over B multiplied by the reciprocal, so it'll be C over D. And that allowed me to say I have negative 3/2 multiplied by the reciprocal of 3 over 1, which is multiplying by 1/3. So I end up with a negative 1/2. I think that's what you're asking me. If it's not, let me know. Okay, so going back to the increasing and decreasing, when we talk about the function being increasing or decreasing, we're asking us, is the graph as I read it from left to right, is it going uphill? So as the graph, as I read from left to right, is it going uphill? Where A is on the left of B, if A is on the left of B, is my output value right here, is that smaller than my output value for B? So as I read from left to right on my axis, are my y values increasing? If my y values, as I'm reading from left to right, are going up, then I say that it is increasing. Now notice, the way we define it is that we don't include these endpoints. And that's going to be important when we talk about the maxima and minima. So we don't include the endpoints when we are looking at increasing and decreasing, or constant for that matter. Again, if my outputs are increasing, they're getting larger as I read from left to right, then we see the graph is increasing. Or we say the function is increasing. Now if I have the graph, I can just look at the graph and say, okay, I can see it looks like it's going uphill. If I look at from A on the left, and here is my output, and B on the right, and here is my output, as I read from left to right, if my outputs are going downhill, in other words, they are decreasing, then we say the function is decreasing on that interval. Once again, we have open ends. So the way we define increasing or decreasing is on for some open interval from A to B. The output f of A is less than f of B, then we say that f is increasing on that interval. Similarly, from the open interval from A to B, if f of A is larger than f of B, then we say f of x is decreasing on that open interval. And then the last one is constant. And with the constant, you can see here's my A, here's my f of A, here's my B, here's my f of B, and we say on some open interval for every single A and every single B in the open interval from f of A equals f of B. In other words, my outputs are exactly the same. then we say that my function is constant. What kind of questions do you have? So here's a graph. And when we're talking about the intervals of increasing and the intervals of decreasing, it is the x values that produce the motion of up or down in terms of the y values. So when we say we are increasing on this interval. So in this region of x's, we are increasing. And then on this region of x's, we are increasing. So if we're asking for the intervals of increasing, then we would say it is increasing from negative infinity to negative 2, non-inclusive, because we never include the endpoints, union with, the next time I see the increasing, the x's that produce that are 2 to infinity. Now, the region that's decreasing is from negative 2 to 2, so in this region, I am going downhill. In this region, these are the y value, or the x values that produce that downward motion, just as these are the x values that produce this upward motion. So the intervals of decreasing are just negative 2 to 2. When we are talking about the intervals of increasing or decreasing, the intervals are just the x values that produce the increasing, decreasing. So when we're asking for the intervals, we are only asking for the x values that produce it, and that's it. What kind of questions do you have for me? I don't actually have any increasing or decreasing. I'm just standing there simply at the very top, and I can't go any further. And I haven't started down. So when I hit the maxima, which is what we're going to talk about in a minute, then I am no longer increasing nor am I decreasing. Once I hit the minima, which is the very bottom or the valley, I'm neither increasing or decreasing. So the point in which we change between increasing and decreasing, these are never inclusive. So those are non-inclusive. Because at the changing, when I'm changing from increasing or decreasing, we're going to call those maxima or minima. And we'll call them extrema, which is what we're going to define them as in a minute. What other kind of questions do you have for me? Yeah, so the other question was, just looking at the graph is going to determine, if you have a graph, absolutely. If you can just look at the graph, then we're just trying to figure out what x values produce an upward motion, climbing the hill, which ones are producing a downward motion, or in other words, going down the hill. Mathematically, we say as this region, we can see that that's increasing by definition. My outputs, as I go from left to right, are increasing. The outputs are getting larger. And the same on this region, my outputs are getting larger as I go left to right. And then, of course, my decreasing is where my outputs are going smaller from left to right. So uphill or downhill. What other kind of questions do you have for me? Oh, 1.3 was where we are. Should not be due tonight. It should be due on Monday of next week, just so you know. Somebody had asked me about that. So 1.3 should be due on Monday of next week. So let's look at an example here before we leave. Before we leave, go ahead and try this. Determine where my intervals of increasing and decreasing are. So I'm going to go ahead and put this on pause. We're going to go back to absolute maxima and minima tomorrow. But what I'd like you to do is I'd like you to try to find the intervals of increasing and decreasing for this example here. Let's talk about these two examples. One of the questions that came up while I paused it was how many union symbols that I need to use. Well, before I get to this, if I had a graph that looks like this, then I would need to use many union symbols to show the intervals of increasing and decreasing. Because in this region, I'm increasing, in this region, I'm increasing, and then this region, I'm increasing. So I would need 2 union symbols to union all of those. And similarly, this is where I'm decreasing, and this is also where I'm decreasing. So I'd need at least 1 union symbol there. If that's the entire graph, then I'd need 1 union symbol. So the number of union symbols depends on how many sections you need to join together to show increasing and decreasing. So going to this example here, the interval that is increasing is in this region. These are the x values that show increasing. So the increasing on this goes from -4 to 1. In this region, I'm constant. So my constant is the interval from 1 to 3. And then in this region, so this region is constant. And then in this region, I am decreasing. So decreasing from 3 to 5. I put 45 because I just like 45. 3 to 5. Is there any questions on that one? Now doing the same kind of work on the second one, as you can see between -4 and 1, I am decreasing. So let me do it in the same color. Let me do it with red. So I am decreasing between -5. So this is decreasing from -5 to 1. Now notice that they are non-inclusive. And then my increasing, which I used in green, is from 1 to 3. So in this region, I'm increasing. And then I'm constant between 3 and 5. How was that? Does anyone have any questions for me? All right. Tomorrow, when I see you all, we're going to pick up maxima and minima and how we define it and how we write it. And then we're going to do some examples with that. We're going to do an example like this because on the homework, you're going to see something like this on the homework. So I want to make sure that we cover something like this before you leave this section. So tomorrow, my expectation is we will finish up this 1.3 and start 1.4. And if this is set due tonight for some reason, because I didn't change it, I will make it due Monday of next week. You all have a great day. Just go ahead and if you need to join my office hours, you should be able to. I've figured out how to see when somebody's waiting to come in, or if it's easier for you to schedule an appointment because you want one-on-one, we can schedule it. And I apologize, Ben, to you because I forgot to meet with our scheduled yesterday. Schedule an appointment. This time I'll remember if you are scheduling outside of regular office hours that I will put a timer on my phone to remind myself to go in and meet with you through WebEx. Have a great day.